Alright, so welcome everyone. Today we're actually learning the oxoacids of phosphorus, and this is the first part of our Chemistry 180 series. So, as you can see, oxoacids of phosphorus in the NCRT, they're given a table and it consists of the name, formula, oxidation state, characteristic bond, and their number, preparation, even their structures. So all of these are important and questions could be asked from any part of it in any way possible. So we'll have to be ready for it. So I kind of brought up a simple, easy, nice method for you to easily remember, because I kind of found there was a symmetry when you're learning these, even when it comes to the preparation. So that is what I'm going to bring it to you guys. Now, as you can see on the left part of the page, I've written all these: H3PO2, H3PO3, H3PO4, H4P2O5, H4P2O6, and H4P2O7. And lastly, we do have HPO3 enzymes, which comes from metaphosphoric acid. But let's focus on the first six first. So in these, there is a symmetry that H3PO2, H4P2O6, you'll have to remember together. H3PO3, H3PO4, H4P2O5, H4P2O7, 5, 7. You can remember it like that. So let me just write it in that way so that it becomes kind of easier. Okay. So let me write it as H3PO2 and H4. One second, my pen is not working fine. I'll have to do it like an actual pen just to make it work. Okay. H3PO2, H4P2O6, H3PO3, H3PO4, and then we have H4P2O5 and H4P2O7. You remember it like this. Now let's find out how to remember the name. You just have to remember simple things like ortho, pyro, and hypo. Okay. So now let's see who gets which name, right? We just pink. So H3PO2 stands for hypophosphorus acid. And H4P2O6 is hypophosphoric acid. H3PO3 is orthophosphorus acid. H3PO4 is orthophosphoric. And we have H4P2O5, which is phosphorus. And H4P2O7, pyrophosphoric. So as you can see, simple, you just have to remember hypo, ortho, pyro. You have to remember which one has us and which one has oic acid. So hypophosphoric, that is how I've kind of separated them into three different pairs. Now, also there is another important thing you might have to remember with respect to H3PO2 and H3PO3, which is they also have a different name. Like you guys might have a nickname, right? So this one, H3PO2, which is hypophosphorus acid, is also known as phosphenic acid, like a phoenix, right? And orthophosphorus acid, H3PO3, is known as phosphonic acid. Okay? I don't know why, I just remember it like phoenix and phone. So you can remember it in the way you want, but this is the kind I'm doing it. Alright, next let's go to the oxidation state. And for oxidation state, it's very easy. You can do it with X method. I'm sure you know what X method is. Let me just show it to you guys real quick. Let's take an example of, let's say, H4P2O5, okay? gonna put it as 4 plus 2x minus 30 less than 0. So you're gonna have 2x minus 6 is equal to 0, you have 2x is equal to 6, and x is gonna be equal to 3. So basically for pyrophosphorus acid, it's gonna be plus 3. Okay, in this way you can actually find it for everything. So that's why I'm not writing it down here. But the next important thing that I want to teach you guys is the structure. Structure is the most fun part because you can easily deduce it by yourself. So let's move on to that right now. Okay. Right. So the important structures are, so let's start with hyperphosphorus acid H3PO2. With the formula you can easily do it. So every time remember a phosphorus would have a double bond O, and let's see where to put the other hydrogen and the other oxygen. Bond another oxygen, and you have 3 hydrogens. Let's put one oxygen here, another here, and another here. Does it make sense? Maybe not. Let's do the next one. Next one, I'm going to take you to orthophosphorus acid. So it's similar to the previous one, but just think how else can you put it. P double bond O is there, oxygen's there, there's another oxygen, I'm going to put it right there. There's 3 hydrogen, one here, and the other here. Got it? Still not? Let's go to the next one. So we're doing orthophosphoric acid. P double bond O. How many oxygen more? 3. We have 3 hydrogens, so pair one with each. There you have it. Your beautiful structure. Now, the most important and confusing part, I would say, for me personally, was the hyperphosphoric, pyrophosphorus, and pyrophosphoric, because these kind of have a different kind, if I'd say. But always remember, they have the same general thing that we do to make these structures as well. Okay, let me do them. So let's start with the 5. So how we're going to do the 5 is, we have 2 phosphorus, just put these, and you have 4 hydrogen. So put these, and there's one more oxygen. You're going to have a POP bond. Okay, you might have to actually remember how it actually looks like, because there's not really a similarity. Because let's see, I do the next structure and you'll be still more confused, because in here you have 2p, and P double bond O is a must, and OH is a must. 6 O are done. These are done. It's gonna end in a PP bond. Okay, let me move on to the next one, which is H4P2O7. So here you have 2p, double bond O, double bond O. Let's see, I put 4 like I usually do. There's one more oxygen left. That's gonna form a POP bond. So always remember, with respect to this higher ones, there's always 4 OH bonds that are with the phosphorus, and each phosphorus having 2 OH. The double bond O, the POP or PP, it is easily observable if you know these 3. There's just 3, okay? So there's not much of confusion. Even if you're trying to reduce all the 3 while solving a question, it's not going to take much time. So just be chill with it, okay? So these are the important structures. Now let me move on to the preparation. And also guys, important, just like they've given in the NCRT, they're not going to ask you the structure sometimes, and they'll ask you it has two POH bond, it has one PH bond, and it has or one POP bond. So if you know the structure, it's easier so that you don't have to by heart it. But if you do have another way, please do pin me down in the comment box. Alright, moving on to the preparation, which usually people get scared of. But we're gonna make that into a bliss today, right? So let me just kind of copy this once more. Just, yeah. Let me copy that and let me paste that here. Good. Okay, so we've divided these particularly in three pairs, and the preparation also kind of aligns with this, and that was the beauty overall, I'd say, because that made things easier, so much easier for me. So let's start with our normal hypophosphorus acid. It's got something to do with white phosphorus and alkali. Cool. H4P2O6 had to do something with the red phosphorus and alkali. Similar? Okay, it's not going to be similar anymore, but it's going to be similar for a pair. Orthophosphorus acid. It's got P2O3 and H2O. Orthophosphoric acid, P4O10H2O. Remember P2O3H2O, P4O10H2O, okay? Simple. Pyrophosphorus, phosphorus and phosphoric. For phosphorus, you have PCl3 plus H3PO3. Now, do you know what H3PO3 is called if somebody suddenly asks you? Well, since I've learned it, I know that it is orthophosphorus acid or phosphonic acid, but with practice and hard work, you'll easily be able to answer it anytime anybody asks you. And in the exam, you're just going to take seconds to answer it. And you know how worth it is to answer a question very quick, right? Accurately too. Okay, pyrophosphoric acid is, they've just given heat phosphoric acid. Now, another important thing also, let me just write that down first. And what is phosphoric acid? It is basically H3PO4, okay? Now, a simple thing you also have to remember would be phosphoric acid and phosphorus acid. This is kind of the gentle things they use in even different chapters. So you might know these detailed names, but if you don't know the simple ones, it's going to be bad, right? Phosphoric is H3PO4. Phosphorus is H3PO3. So basically H3PO3 got so many names. Phosphonic, orthophosphorus, phosphorus acid, okay? Right, so as you can see, there's a, comparison here as well. So H3PO2, white alkali and white P4 and alkali, hypophosphoric, red P4 and alkali, orthophosphorus, P2O3 and H2O, orthophosphoric, P4 and P4O10 plus H2. Pyrophosphoric, you have PCl3 plus H3PO3 and H4P2O7. Pyrophosphoric acid, you're just gonna heat H3PO4. Now, they will also ask you for metaphosphoric acid, which is HPO3 N times. Let me write that down as well. HPO3 N times is basically being called metaphosphoric acid. And remember the oxidation state, it's +5. Now, talking about the structure, there are kind of two structures that I've seen in the NCERT book. There's a cyclic one and there is polymetaphosphoric. So let's see these. So let's start with polymetaphosphoric acid. So simple HPO3 N times only. How is it represented is, so there's always P double bond O. there's always a OH. The other side we're gonna have a O. PW want O, OH. On the side we're gonna have a O. Simple. This is how it's working. That's all. And that's a discrete continuing unit. There's also another which is cyclotrimetaphosphoриc acid. This is polymetaphosphoric. Now we're going to learn cyclotrimetaphosphoриc acid. And this is also a nice diagram. So you have trimeta, right? Put 3p. And between each p, you're going to put an O. But I think let's go with the NCERT kind. P's are here. The O's are here. Okay. Bond. Do something like a benzene. And you know every P should have or must have a double bond O and a OH. Simple, easy, fun, right? That's the most important, fun. Okay, above all, you also need to know the preparation. So here the preparation is phosphorus acid plus Br2 heat in a sealed tube. Phosphorus, what will we tell? We just learned it's HCPO3 plus Br2, and you're gonna heat in a sealed tube. See, sometimes they might just give unsealed or stuff like that. See, that's where you have to be extra careful. Phosphorus acid plus Br2 heated in a sealed tube. Cool, okay. We're done with the whole oxoacids of phosphorus. Just see how easy it is once you find out. See, everything is about symmetry, makes things easier. I don't know, in physics as well, in those circuit kind of questions, when you kind of find out the symmetry, you kind of easily will be able to solve them. So you see, in the same way, anywhere in any part of the NCERT, even if it's in biology, you find the symmetry, you'll kind of have a way to remember it easily. And it'll be very fun because symmetrical things are great, right? I don't know why I'm talking philosophy. I don't want to talk more. Anyway, this is the end of the video. I really hope all this helped you guys. If it did, please put it down in the comment box so that I know how it helped you guys. I'm not gonna talk a lot. See you. Bye bye.